Hello everyone, this is Boan Li. Sorry I don't have a webcam, so this is my face. And I'm going to share my screen. Here it is. Hello, our language name is Brewless. And my name is Boan Li in the project SER 502. So let's go to the overview. We provide a basic framework for a simple programming language that can handle basic data types, arithmetic operations, logic operations, condition statement, loops, and outputting. With some additional features and construction, this language could be extended to support more complex applications. So for the design of the language, our language describes a simple programming language that includes basic programming we mentioned before, like constructs like declarations, assignments, conditions, loops, and printing. The language supports three types, int, string, and boolean, just similar to the language in the Java C, and allows for arithmetic operations and logic operations between boolean expressions. So we make it keep similar to Java and C and Python, and it's supposed to be an imperative language. So we will be using Lex to tokenize the program. We will be producing our Lex threshold analyzer and phaser tree using DCG, and creating our semantic analyzer and running time environment with Python. Below are some explanations for the different grammar rules. So here's a program. We have program baseline. Starting point of the program can contain a block called a single command, and the block, and the command and declaration. So this is a type and identifier used to declare a variable, which is very important. Type, which we mentioned before, is int, string, and bool. Assignment and expression, which is a term of programming statement. And here is a four-kind calculation part. Is multiplication, the operation of two expressions, the derivation, mathematical derivation, simply, yeah, so we don't need to explain too much about addition and subtraction. So let's go to the identifier. It's a variable with a value that may be changed. This contains either a single character or letter, or potentially multiple letters, which will store data. And we have 0 to 9 digital digits, integer, which with any whole numbers, later, which with lowercase. We also add the uppercase into it. The boolean true or false, classic. The string, which is specific, identifier not used specific for variable name but stored as data. And conditional, ternary, and for loop, and while loop. For both of loop, we have two types of loops. Which one? The first one is traditional one, and the second one in the for loop is a range for loop, and the while loop is a do while loop. So the loop update is suppose the for loop, which help to be a range for loop, and increment, decrement, and finally the print. So you can see here is a grammar for our program. And here is a SWDCG parsing, which extends the program and try to run it, test it. And here is some screenshot of our compiler, which our other teammates will mention in their videos. And snapshot, and here is 5 test sample we use. Thank you.
Hello, my name is James Thayer, and I'm going to be going through the lexical analyzer and the tokenization process for our program, Brewless. So, without further ado, our program starts off by having a regular expression pattern, which will match the various types of tokens, and we define all of these types as constants for later use, and also it can show the token type if you want, so easy for debugging and stuff like that. So you can see all of the types we use here. There's quite a lot, and we also have a generic error handler as well as an illegal char error, which inherits the class error from the generic error handler. So that way, if there is an illegal char expression, it degrades gracefully, and it shows you, it gives you that feedback. Now, we have our lex function, basically, which takes in an expression and it'll return a list of tokens. So first it iterates over all of the expressions, over all of the tokens inside of the regular expression, and it'll find anything that matches. And then when it does that, it'll determine what type it is. And so it'll assign the type and append the value at the end of it, and add it to the list of tokens. So then, if an invalid character is found, it raises the illegal char error. And so this should go through all of the tokens we have defined and print them out. So I have an example file here. If we have some example code where we have this expression that I'll pass along, and it'll just return tokens while it's running. So let's give this a try. And I can just enter, and there it is. You can see all the tokens at the bottom here brought up. You have your if statement, your for, prints, comparisons, conditions, everything. And that's it for the lexical analyzer. Thank you.
Well, and I'm Tahir Pervez from Group 2, and for our Brewless code, I worked on the DCG portion. Let's go ahead and share screen. So now for a program is going to be a block within curly braces. A block is a command list. It's a command followed by a block, or just a command. The commands can be declarations, assignments, conditions, for loops, while loops, ternaries, and or just different declarations. You don't necessarily have to be assigning one. You can simply be declaring it of the types being int, string, or boolean. Assignment, where you assign an actual value to the identifiers. These are expressions with orders of operations included into them, and it can be adding, subtract. It can be complex ones, or it can simply be a single value. Integers are just integers, while strings work function, or identifiers are function as atoms, while these are also our strings. Booleans, we have for straight up true or false. We have equivalency, nots, and ors, and then less than and greater than. For a string is written as just string, the name, and then a actual string value, which is identifier sharing with. We have ifs and if statements and if else statements. As the turning a funny one. Then we have our for loops with allowing for both standard ones as well as we're utilizing a range, and we include both while and do while loops. These are our incrementers. This is just a simple print, and this is the range for helping.
Hello, my name is Michael Kangas, and I did the parser for our Brewless language. This is the parser for our language, coded on online on the Swish Prolog page. It's pretty standard. Takes in the parse tree, which for convenience I have basically the predicates in my online development environment, and calls in similar to how it was done in assignment 3, a string of tokenized characters from our lexical analyzer. Here I've got a set string of tokens pulled from the lexical analyzer earlier, as well as have it currently set up to display not only the output environment, but as well as the parse tree after we create the parse tree and then evaluate it and get our output environment. Speaking of which, the parser runs the parse tree through it, and during the process creates an environment of the different variables, their types, and their values by looking them up and updating them with these predicates down here, and running through it. These eventually make it back up, and we get our output environment, out env for short, and it is this that we end up printing to show that the code was actually done. As an example, here is the running of a tokenized while loop, a do while loop specifically. And as you can see, it successfully counts through. There is the issue of multiple productions, but the first one is the one we want. That has been accounted for in a later portion of the complete program.
Hi, my name is Jacob Jose. This is the demo for SER 502 project. So I have done the part where the a Python file is going to compile our Brewless programming language. So I'm just going to share my screen. Okay, share my screen. Share. Okay, I'm now sharing my screen. So this is the. Let me just. Okay. So this is a Python file that is going to take the tokens and call the prolog file. This is a program sample program number 1. So this is going to take 2 numbers and find their product. So I'm going to run it. So before running, in order to run this program, what you have to do is you have to have the sample program and our Python files in the same directory. Once you have that to run it, you just have to call. This is written in Python, so this is going to be Python 3 followed by the Python file that is going to compile the program and let us run sample program number 1. So when you run the sample program number 1, it is going to return the output and also the environment state, that is the state of variables inside variables in that program. So now I'm going to run the sample program number 2 before I run sample program number 2. This is a sample program. So this is just printing numbers in a loop. So let's go into sample program number 2. Here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The numbers in the loop, they are not formatted because there is no new line. So I'm going to run the sample program number 3, which is just going to set the value of variable count as 10. It is just a for loop example. So running sample program number 3. So for this program, there is no output because we are not printing anything. We are going for sample program number 4. This has if-else condition. So this is going to print either 5 or number 3 according to the value of the variable. So running program number 4. We got the variable number 3 because the condition for 3 was executed. Here it is false, so this loop won't be executed. So the else part of the if statement got executed. Now sample program number 5. So this is sample program number 5. So it is going to print the number count, the variable count. Okay, so this is running. It has printed that. Thank you. So